So today I'm going to be we're going to be doing a workshop on Terraform and infrastructure as code systems. And I have whole slides that explain what I was about to get ahead of myself on. So for those of you that don't know me, my name is Mason Egger. I'm a developer advocate at DigitalOcean. Here are some things if you are curious. If you want to get a hold of me, you can always tweet me if you have any questions. Email me. I do live coding stuff now as part of my advocate job, and every now and then you'll actually see me working on the DigitalOcean Terraform provider because I am one of the maintainers of that. So if you've ever been curious about writing your own DigitalOcean or your own Terraform provider, which I would say is probably one of the more advanced steps of using Terraform, I'm happy to talk to you about that because it's a pretty interesting process. It's what happens when you give Golang to a bunch of Ruby developers and they haven't learned all the Go idioms yet, so you get Golang that looks like Ruby. And it behaves kind of weird, but it's really cool, and it's actually a pretty neat system to work with. So ignore the word webinar. Today's goals are we're going to learn about some infrastructure as code. Basically, what is it? What are the benefits? We're going to learn about Terraform, the different offerings that Terraform provides, how to install the Terraform CLI. We're going to do some getting started with Terraform. We're going to talk about like Terraform primitives, standing up different resources on DigitalOcean using Terraform. And by the end, you should have a small load balanced stack infrastructure that we can stand up and destroy with a single command. So you'll have a web server basically behind a load balancer, and it'll just forward your traffic straight through all nicely for you. If you'd like to follow along with this, you're more than welcome to watch, but if you'd like to follow along and actually do it with me, I'm going to be mostly reading my stuff off of my GitHub repo, because when I first did this, I actually took the time to write out very in-depth instructions for myself so I didn't forget a step. So if you want to go along with it and you don't want to just type along, you want to go with, because I'm going to live code it, but if you just want to get the finished results, I've got it broken up into the parts. It's at this short link, do.co/IAC-webinar-code. I'll be live coding it during this. If you don't have a DigitalOcean account, you can go to do.co/Mason. You can just use my first name. I've got a vanity URL for $100 credit to play with. If you do have a DigitalOcean account and you want to play along and you need a little bit of credit, we can do that at the end. Just send me, like, you can either message me privately on Zoom or DM me on Twitter, or email me with what your DigitalOcean account is, and I can drop $5 or $10 into your account. So that way you can do this without having to worry about spending the money on it. We just don't have we don't have codes for that. I have to go manually do it in the system. Just so you know that as we do spin up infrastructure and tear it down and stuff, those will start to incur charges. So it's going to be pennies, to be honest, because we're only going to have a droplet and a load balancer up for maybe 30 minutes. But if you forget to destroy your infrastructure and you just leave it there, it will incur charges. So just be wary about that. And I'll make sure at the very end to repeat multiple times, make sure you've deleted your infrastructure if you don't want to keep it and you don't want to pay for it. Luckily, I always use the cheapest options possible, so it's only going to be like a $5 droplet. Okay, so we're going to do a quick little intro on what infrastructure as code is for those who may not know it, and then we're going to get into the coding. So what is infrastructure as code? Infrastructure as code is really the management of infrastructure using tools that take configuration files, which are usually declarative files, and these tools accurately provision hardware to a known good state within every execution. And that's actually one of the important parts, is that it's a known good state. We don't just leave infrastructure as code files out that are broken. It's bad. You expect your infrastructure to come up in the same state every time. That's kind of the whole purpose of it. So which is kind of where idempotence comes in, which is one of the core principles of infrastructure as code. And as someone who doesn't use big words since he's left college, I had to remind myself what this meant. And basically it means that the execution always renders the same state, regardless of the state that the system is currently in. It could be in a half state, it could be in a full state, it will render it. A great example to demonstrate idempotence is kind of elevator buttons. When you first push the call button on the elevator to bring the elevator to you, it starts the bringing the elevator, but you can push it as many times as you want. It doesn't change anything. So once we have our infrastructure stood up, we could rerun Terraform apply 100 times. As long as the state file didn't change, the infrastructure will not be touched. So that's kind of the whole purpose of infrastructure as code. What are some of the benefits? It allows for reproducible infrastructure, which is very valuable. If you've ever worked in large scale systems where infrastructure is more than a couple of servers. I used to be a site reliability engineer for Expedia Group, specifically for the Verbo brand. So we had thousands of cluster nodes in our cluster. You want those to come up the same every time, and you want to be able to say with some pretty good confidence that if I do have to spin up another cluster in another region, or for some reason maybe the whole cluster came down and I have to spin it up really quickly, that it will be in the same state as when I last ran it. Otherwise, we might be looking for jobs. It's easily redeployable, which is actually one of the great things about it. Is like we'll be able to deploy what we do today with DigitalOcean with Terraform, but then we'll be able to go and say I want to put it. I don't want to put it in New York City's data center. I want to put it in San Francisco data center. I can easily redeploy it into another data center with almost little to no change in the code whatsoever, which is really nice. It is a solution to infrastructure drift, which anyone who's ever managed a server for more than about a month or so, you start to realize that you do little one-off things on servers. Like one of them is misbehaving, so you go and tweak something on it. Eventually, infrastructure drifts. The longer your code is up, the longer it's running, the more likely it is that you're going to manually intervene at some point. And when you do this, those changes get lost. And then if you don't commit them, or you don't document them, or you don't put them in some sort of code system, then whenever the system does come down or you have to do a rebuild, you don't remember what you did, and then nothing works, and it's a whole mess. So it is a really nice solution to infrastructure drift. It can be stored in version control systems, so you can actually have versions of your infrastructure. I can go back at any specific day when I was at Verbo and say, this was the version of the Terraform file that ran this infrastructure. So I knew exactly what state the machines were supposed to have been in, as long as nobody SSH'd into them, which we usually didn't allow much of that. It's easily automated. It's really nice. It goes really good into CI/CD pipelines. Hashicorp, the company that created Terraform, did a great job with this. So as I'm describing all this, some people might be saying, hey, wait, I use Chef, Ansible, Puppet, Salt. There's a lot of them. Isn't that infrastructure as code? And first, I'm going to preface this with, that's a gray area. It depends on really where you stand on it. I'm going to tell you my opinion of it. And my opinion of it is those tools really are more configuration management tools. They configure resources that are already provisioned. Now, can you use them to provision resources? Yes. Can I use Terraform to do configuration management? Yes. I don't recommend it. I feel like demarcate that line pretty heavily and be like, this is what manages the infrastructure, this is what manages the configuration, and the tools work really nicely together. So when you provision something, that's a hardware or OS level. There may be a base set of packages that you install because you know they're going to be on everything. That's okay. You may pair Terraform with a tool like Packer, which essentially is a tool for building OS images, and then that way you kind of have a golden image that you deploy. So you would provision that in the hardware, and then once that is done, then it would signal to a configuration management system, hey, I'm done provisioning, now it is time for me to be configured, which is exactly what we did at Verbo. It's a very eloquent system. I like it. Use the right tool for the right job. You can make them do it, but they don't like doing it. I've tried doing configuration stuff with Terraform, and sometimes it just it makes my head hurt. These tools do not replace each other. Infrastructure as code and configuration management are not, they're not like fighting out for your love or something. They work together, and you get a really nice system when you blend them harmoniously together. So I always recommend that. I've worked personally with Puppet, Ansible, and Salt. Puppet not by choice because it's Ruby, but Ansible and Salt. And every time I've done it, it makes your life a whole lot easier. An example of this would be, and this is exactly actually what we did at Verbo, whenever the provisioning system, whenever we would use Terraform provision a server, and when it was done, and basically in Cloud Init set up our Puppet repos, and then once it was done, it basically, the last step it was installing Puppet, making Puppet run, telling it where the server was, and then it would do a Puppet apply, it would go down, pull the config down, and they would basically chain the reaction together. So as soon as provisioning was done, it would hand it over to the configuration management system automatically. It would pull down the config for whatever type of server it was. Was it a console server? Was it a Vault cluster? Was it one of our Mesos nodes? Was it a Nomad node? And then it would do the appropriate configuration for each. So that's a good example of that. So today, there are a handful of different configurations management tools. Like I said, you can kind of use the config management tools for them, but I don't recommend it. The main ones that I know of are Terraform, and then there's one called Pulumi. Today, we're going to talk mostly about Terraform, or pretty much all about Terraform. I'm still playing around with Pulumi. Eventually one day I'm gonna write a Pulumi talk because it's a pretty cool tool as well. But Terraform is a open source tool built by Hashicorp. There are enterprise versions of it. If you've never heard of Hashicorp and their model, basically almost all of their tools are pretty much open source. And then there's an enterprise mode that kind of adds on some extra functionality to it. But in reality, we ran Verbo on all open source Hashicorp. So we're talking billion-dollar business running all of our infrastructure using Console Vault and Nomad and Terraform, and we didn't get enterprise until we had a very major console outage. That was our fault, by the way. And then we decided we wanted to support. But you can run your entire business on the open source version of the Hashicorp tooling. It's fantastic. There are two main offerings of Terraform. There's the Terraform CLI, which is what we're going to be covering today. You run it locally. You can install the CLI into your CI/CD system and run it, and that's awesome. Then there's also Terraform Cloud and Enterprise. Cloud is essentially remote state management with CI/CD integrations. So if you wanted to run, if you didn't want to be running it from a laptop or setting up a Jenkins box that has like a Docker image that has Terraform installed in it and then downloading and running it, you could do this all through Terraform Cloud. It has some nice integrations. Pretty reasonably priced, honestly. Tiered levels, I've never used it, but I've looked at it and I'm like, okay, I would pay that. The enterprise version is essentially self-hosted distribution of Terraform Cloud. If you work for one of those companies that doesn't like cloud or SaaS offerings, I used to work, my first job was working for a Raytheon subsidiary cybersecurity company, and we weren't allowed to have SaaS offerings. So if we wanted anything, we had to be able to host it in-house. So that's essentially what Terraform Enterprise is. So Terraform has hundreds of provisioners for managing many different types of resources. There's one for Kubernetes, there's one for DigitalOcean, there's one for AWS, there's one for GCP. Datadog is a really fun one that I like using Terraform for. Prometheus, all of that. So you can configure almost anything with Terraform, which is awesome because like today I'm going to go through and show you how to use Terraform for standing up stuff on DigitalOcean. But you're going to be able to totally use it for AWS. There's no, you have to, maybe the stuff that you actually write is different, but the base structure and how you run all of it is essentially the same. There is also a registry of community-built modules for building different types of infrastructure. So if you just want like to stand up, say, I don't know, maybe there, I'm pretty sure there's an AWS Kubernetes cluster one. You could go and it would download basically all the code for it, and you would just run it. And this is like, the AWS teams put it together. Like, this is how we would recommend standing up a Kubernetes cluster. You can just go and download it and run it, and that's pretty awesome. Very recently, all of the providers have been migrated to Terraform registry. So it used to be that Hashicorp did them on their own, and now there's the registry, and the registry was like the community stuff. Now it's all together. So if you are used to going to a certain place, if you've ever used Terraform before and you're used to going to a certain place for the documentation, it actually moved, and it keeps breaking. So hopefully it's not broken by the time I get back to showing it to you. They have something wrong with their CDN and their CSS keeps not loading. It's happened for like 2 days in a row now, and it's making me cranky. So if you want to install it, or if you haven't installed it already, you go to terraform.io/downloads and you find your operating system, download it. I think it's a zip file. It's a single binary. It's all Go files. So all of HashiCorp's tools minus Vagrant are written in Go. So everything that they run is a single binary, so it's super easy to install, which I really like. And okay, so enough talking, we're actually gonna start building stuff. So the first thing we're gonna talk, this workshop is in 4 parts. And the way that I kind of run this workshop is, it's very different from any other Terraform documentation that you may have seen. I approach this as if the way that I would teach a computer programming language, whereas Terraform usually just, let's stand up an instance and talk about it later. We're going to talk about variables. We're going to talk about namespaces and stuff like that. And we're going to do it kind of in a, like how you would, if you were taking a CS 101 course at a university, kind of in the same similar structure for that. So, because I wanted to do something different and I was bored. So the Terraform providers, part 1, we're going to talk about the providers, which are basically modules for different resources. DigitalOcean, Kubernetes, Datadog, AWS. We're going to talk about data sources, which are ways of getting data from your provider. So you can get account information, you can get resource data. These are basically read-only tools that allow you to get data from the provider as you need it. We're going to talk about variables, which are essentially just like variables in any programming language. And we're going to talk, and that's going to be part 1, and it will go relatively quickly. So is that large enough, or do I need to make that bigger? It's always the question we have to ask.
Great.
It's
easy to see.
awesome. Good. So I have a meetup folder. So the first thing we're going to do is we're going to open up main.terraform. Now you can name these. Is that what I actually did? Let me double check. Yes, it is. You can name these whatever you want. Main.terraform is one that is one of the, I believe it's one of the names that automatically gets picked up and ran by default. So if you just, it makes life a little bit easier if you do that. But I've definitely seen it done differently. And the first thing we're going to do is we're going to say, hey, we want to use, come on, Vim. I know it's been a while. That's, my hands aren't in the right. Interesting. The P was an I. Okay. We're going to go ahead and just say we want to use the DigitalOcean provider. And we're going to set its token. So what we could do here is we could set my happy token. But this is hard coding stuff into source code that's going to eventually wind up itself in Git, and that's how you get pwned. So we're not going to do that. We're going to use a variable var.do token. So anytime you're using a variable inside of Terraform, it's called var, and then dot, and then the name of the token that you want to do it. If you've ever seen, if anybody here has ever worked with Terraform before, and you're used to seeing this syntax, if I could find the parentheses, this is old. So in Terraform .12, they changed their variable interpolation syntax. So this used to be the way that you would interpolate variables inside of Terraform, but they have now since changed that. So we're going to go ahead and just quit that real quick. And then what we're going to do is there's multiple ways we could set these variables. We could create a variable file. We could hard code it. We can set it up using the Terraform command line. My favorite way personally is to use environment variables, which is another thing that would be really useful in CI/CD system. So what we're going to do is we're going to export tf_var_, and then it'll be the name of your variable. So mine's all lowercase do token, and then I would put some stuff in here, and I would hit enter, and it would export it. I've already exported mine, so I'm not going to hit enter on this command. But this is how you would do environment variables for any part of Terraform. It doesn't just have to be the DigitalOcean token. So what I'm going to do here is I'm going to go back to the Terraform registry, if the Zoom controls will get out of my way, and hope that they have fixed their CDN. They have not. This is going to make life really fun. This has happened like twice in the last couple of days, and it's been mildly peeving me.
Nothing like a live demo.
Yeah. Then the thing is, not my fault. I do not maintain this website. Whenever their CDN is down, it is not my fault. So this is going to be fun to figure out how on earth I'm even going to. The good thing is I have most of these docs memorized because I wrote some of them. But okay, we're going to imagine that there's a beautiful page, and you can easily see all of the things that I want you to see. And I don't want DigitalOcean latest. I want like the firewall, or I want something. Give me something. Okay, well, no, we're good. Okay, well, I'm gonna be cranky about that and tell my other co-maintainer that he needs to tell Hashicorp to stop breaking their CDN. Anyway. One of the nice things you can do is their documentation, which if it was being nice, I could show to you, basically will walk you through how to do a lot of the thing. Every single item will be what's known as a resource or a data source, and we'll be able to see like droplet or database or things like that. So the next thing we're going to cover real quick. So this is how we've done our, yes, we've done, let's go ahead and do a Terraform init. That's what I want to do. Cool. So basically what this did is this directory now has a .terraform directory, and now we are essentially, this directory will now run as a Terraform provider. So I can actually run a Terraform plan, and it should say no change. It says no changes to infrastructure is up to date. I'm pretty sure it went and tried to check to see if my token was valid. So if it didn't, we'll find out in the next one when I apply something. So now that we've done this, we're going to go ahead and add what's known as a data source. So there are two types of data sources that Terraform provides, or two types of resource, kind of quote unquote. There's what's known as a data source, which is essentially a read-only way that I can go and I can see things from my account. And then there is a resource which will actually create a resource like a droplet, like a database or something. So the next thing we're going to do here. Now the fun thing is that worked without me having to. We're going to find out if I did this wrong. We're going to go ahead and do data and then DigitalOcean underscore account. And then I'm going to go ahead and give it a name called account info. And we're just going to do open and close brackets. So we're going to go ahead and go over this really quick. Data tells me what type of resource it is. So this means that this line particularly will be getting me a data source. DigitalOcean account is the magic variable that you read from the docs that are currently broken that tells you what it is. I would like to get data source information about my account. And usually the variables are preceded. So if this was, all DigitalOcean ones are preceded with DigitalOcean underscore. So if I wanted to get information about a droplet, it would be DigitalOcean underscore droplet underscore database underscore load balancer. This one, we're just going to get information from our account. And then account info is just a really nice variable for us to be able to reference this in other parts of our Terraform. And these are these open and close parentheses. If there were variables that were necessary here, like maybe I needed to provide, if it was a droplet, maybe I needed to provide the droplet ID or something, that would expand down and we would add something. But since it's just our account info, nothing's going to be put there. And then what we're going to do currently, or next, is we're going to add what's known as an output variable. So this token right here is what's known as an input variable. And I'm pretty sure I know that this is going to fail, but we're going to check anyway because I'm curious.
You said the word parentheses, but you have curly braces.
Yes, curly braces. I'm really bad sometimes about mixing those up in my brain. Yes, curly braces. 100%. Yes, thank you for checking. If I keep making that mistake, feel free to yell at me because yes, they are curly braces. This variable up here is what's known as an input variable, which we're very used to. We're very used to saying, you know, we're getting input from something. But now we're going to see what's known as an output variable. And an output variable is whenever Terraform is done, I would like it to print out this information for me. So I'm going to get my account, and then I want to know how many droplets my account allows me to use. So what we have to do here is we have to type out all of this stuff longhand, and then the actual attribute we want to do. So data.DigitalOcean underscore account info droplet underscore limit. So the type of resource that it is it a data resource? The thing that irritates me about Terraform is if it's a normal resource, you don't have to have the data there. I wish they would have made the resource, a little consistency would have made me happy. Again, the type of resource we're trying to access our account info. The variable name, and then each of this variable will basically have a whole bunch of attributes. You kind of think of it as a class object with a whole bunch of instance variables. And then droplet limit is the one of them, is the one that we want to see. And I'm 99% sure this is going to fail, but we're going to see. Ha 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 ha, it did. So I did the thing that I used to teach some like undergraduate labs at university, and all my students always did it. They try to use the variables without declaring them. So variable do token, curly braces, is how we would actually declare this variable. I was curious that whenever I ran the Terraform plan earlier, that it didn't complain, and I was curious if it was going to let me get away with it, but it didn't, which is fine. So Terraform plan should come back and basically say nothing. Like there's no changes, nothing's going to happen, because we're actually not changing anything. We're only reading something. If I run a Terraform apply now, it will reach out, and it comes up and says, hey, your outputs, you said you wanted the output of your droplet limit, and because I work there and because this is my work account, I have a very high limit because I do a lot of testing and tutorials and stuff. Most people's droplet limit will be set to 10 unless you have reached out to support before to get your droplet limit increased. So really quickly, I'm going to go back through this. Go ahead. Go ahead.
Add some information before the droplet limit. That's sort of produced by Terraform without you asking for it?
Yes. So all this outputs, all this jazz and stuff, yes. Now the cool thing is I can, nope. What is it? There is a way to make it output just JSON.
Okay.
Come on.
But the thing you asked for was really the very last green.
Yes, the thing I asked for was the very last green line. It'll nicely tell me that there's outputs, and then it basically will tell me, hey, 0 resources were added, 0 were changed, 0 were destroyed, because this is very typical. And actually, there could be a whole lot of other stuff that's going to come output here, because Terraform does kind of show you its progress. So yes, it will do that, and there's a Terraform out. I'm gonna Google it. Terraform output JSON. It doesn't just necessarily show up. Oh, it's the Terraform output command. So yeah, so after you've run the apply, you have now you have seen it, but maybe you don't want to run apply every time you want to see this data. Maybe you're just curious what the outputs were, what the state of the system is in. So you can run Terraform output at any time and just get just the output. So all of this, because as you said, the apply did produce a lot of extra stuff, and it will. If you just want to see the outputs, you can run that, and you just run -JSON to get the value as JSON, and then you'll be able to programmatically take your outputs and get them back, which is really nice. So
I feel like I've seen the variables defined before inside of quotations. Is that just an older syntax?
Are you talking about like on line 4 right here, or
like on line 1, I think.
On line 1, it might be an older syntax. And actually, I don't think it matters. I think that it's, I think I've also declared variables within quotation marks before, and I don't think that it necessarily matters. I think they might have changed that. So let's just try and apply real quick. Yeah, doesn't matter. You can put them in quotes. You don't have to put them in quotes. Totally up to you.
Mason, if you're using a like tf-vars file, do you still have to declare the variables in your main tf?
No, and we're going to get to tf-vars in part 2. So yes, if you're going to use it, you can create a separate variables file, which makes life a lot easier because you'll be surprised how many variables you can accumulate inside of a Terraform thing. The ones we ran at Verbo, we're talking 40, 50 variables. So just a quick recap. We declared a variable called DO token, which is essentially just a placeholder, basically instantiating a variable saying, hey, we're getting ready to have a variable called DO token. We wrote our provider called which is named DigitalOcean, sorry. It takes one variable called token, and then we provided the var.do token through the environment variable using tf_var_ variable name. We read a data source called account info to just see how many droplets we have. And then we read that data, and then we outputted, hey, how many droplets can I actually spin up? I can spin up 1,000, you can spin up X. And that is the end of part 1. If there are any questions, we'll go ahead and I'll take a quick time for anything you have, and then if not, we'll move on to part 2.
Is account_info actually a long JSON or XML list of stuff?
Can you repeat that again? I didn't hear you.
Was account_info actually a long JSON or XML list of stuff, and you just ask about one of its contents?
Yes. So if there account info, again, if I could show you the thing, I would. Account info is just one of the many attributes, but I believe you do have to explicitly state which ones you want. So we can try it real quick because I'm curious and I've never actually tried it. Let's just see if we can output all of account info. I don't think it's going to work. I think it's going to throw an error. Oh, what do you know? It did. Hey, I learned something new today too. So you don't have to just do your account. You don't have to specify something, but the cool thing is those output variables, especially once you start using multiple Terraform files because you have different parts of infrastructure, you can use those outputs to feed the input of another Terraform. Now that's a little bit more than what we're going to cover today, but if I ever write a part 2 of this workshop, which would be basically like Terraform 201, I call this kind of my Terraform 101 talk, I would definitely include that. So yes, there are a lot of other pieces of data that are there. Thank you for asking that. Even I learned something today. Woohoo. Okay, if there's no more questions, I'm going to go ahead and go back to my slide, and we're going to talk about part 2, if I can find them. So part 2, we're going to cover basically simple resources, and we're just going to create a droplet. So let's go back to our main.tf. So we don't actually, we're going to delete line 7 through 11 because that was more just to show a data source without actually using it. Now we're going to use data sources to actively create a DigitalOcean droplet. So the first thing we're going to do is we're going to create our DigitalOcean droplet. And again, I'm going to check the website in the odd hopes that also hopefully the Zoom controls will get out of my way. Please just fix it. Okay, it's not fixed. Thank you very much for that. I guess I should start caching my own copy of the Terraform provider.
It is working for me.
It is? Oh, well, maybe it's just my silly computer. Let me try it somewhere else. Terraform, DigitalOcean. Okay, now it's loading forever. Oh, it's just Brave that doesn't like it. Apparently there's some very nasty script and Brave's like, no, Hashicorp, smack. Okay, well, this is what I wanted to show you in the first place. This makes it's so much easier not to have to fly dark and blind through this. Then we'll go to, where was I? These are the data sources, and we were at account. So as you can see, go put your cluster in an unknown state, then Terraform will very possibly react very adversely to it, or it can potentially lose the connection. Like it may not recognize the resource enough that it will basically leave the Terraform state in a bad state, and then now you've lost complete control over that resource via Terraform. I've seen that happen before too. Basically, the state file gets tainted, and it gets just very unpleasant. So if you are using Terraform, I recommend not going in and tweaking stuff by hand. Let the tool do as much as it can for you, because it does do a pretty good job of it.
I have much real world experience. How does Terraform refresh work?
You know, I actually don't remember which one Terraform refresh is. That's so. What
is the latest other? Yeah, pulls any like other changes that have been made that aren't named parameters. So like if your tags changed and you didn't specify tags, it pulls those into your state file.
Interesting. Huh. Yeah. So let's just look at the Terraform commands. There's apply, console, destroy. I never even knew about refresh. So personally working at, you know, I've used Terraform in production for, we'll say, roughly 2 years. Apply, destroy, output, show, not even show, and workspace were really the ones that I used on a daily basis. Now, it's got a lot more functionality to it. Terraform import's actually really cool because you can use it to actually take a resource that was not originally managed by Terraform and bring it in, and then to where it is being managed by Terraform. That one's really cool. But yeah, so it says update local state files against real resources. That's really awesome. I definitely need to play more with it. There's so much to Terraform, which is honestly like one of my favorite things about Terraform is that I can do everything I need to do for my job with 4 commands, but there's a lot more if I want them. You know, it's not overly complex. Very, very well, in my opinion, very good UX. So,
since you just mentioned it, have you had pretty decent luck with the Terraform import command? Or
depends on how the provider imports or implemented it. I've had good luck with the DigitalOcean import stuff. I implemented the part with the Docker registry stuff that just went GA. And luckily that one didn't have an import, but the droplet one works really well. I've seen it kind of sort of work with AWS, but the AWS stuff their environments get so complicated that sometimes it's just like, no, I can't. Sorry, I can't. That's the one good thing about DigitalOcean, and the fact that it only has like 8 products is it's while you can create some very complicated stuff, it's never going to get to the level of complexity, say, when you have 600 different services that you offer. So
I will definitely say that's the selling point for DigitalOcean is simplicity.
Mm-hmm. Yes, it is. It is my favorite part. It's why I chose to go work there. Okay, cool. Let's go ahead and move on to part 3.
I think you also have a question in the chat.
Oh, I didn't even see it. Let me find it. Chat questions. How do Kubernetes and Terraform compare, or Docker Compose? Okay, so you would use Terraform. You can use Terraform to spin up your Kubernetes. Kubernetes schedules jobs and workloads and such, whereas Terraform just provisions the resources. So we didn't use Kubernetes at Verbo. Mesos is, if you know anything about the container orchestration thing, Mesos was kind of the precursor to Kubernetes in a way. And then we migrated from Mesos to Nomad, which is another Hashicorp tool. But they're very similar. Kubernetes schedules actual like running things, whereas Terraform just basically gets the thing running, and they're like, okay, you can do what you want on top of it. Docker Compose, again, more similar towards Kubernetes than Terraform. Terraform wants to deal with the hardware, and that's all it wants to do with. It doesn't want to go and it doesn't want to be your configuration management tool. It doesn't want to be your deployment tool. It wants to be a hardware provisioning tool, and that's all it wants to do. Cool. Cool. Okay, so I'm going to go ahead and move on to part 3 because I'm trying to keep it within a certain time range. This webinar fluctuates, or this talk, it was a webinar first. This workshop fluctuates very much depending on how much breath I have in a day and all the other things I want to talk about. So the next thing we're going to do is we're going to parameterize our, and I guess we're going to let me go back to the slides. Just because I made this so I know. We're going to use variables to make Terraforms more reusable, and we're going to talk about workspaces, which is basically isolated areas for Terraform states to be executed. Think Python virtual envs whenever you think of workspaces. Whenever I give this talk to other people, I feel like, and Node.js stuff, but I'm talking to Python people, so you hopefully we know what that is, and I don't have to talk about Node.js anymore. It makes my heart hurt. So right now we've created a lot of really cool, do I even get into the variables file? Because somebody asked me about that variables file. I'm gonna check part 4 real quick before I don't even know if I make a variables file in this. Huh, I don't, look at me. Okay. So the next thing we're gonna do is we're gonna talk about the resource, and like, while it is pretty useful, it's very, very limited. Like this stands up an Ubuntu server with one name in one region at one size. Whereas if we want this to be reusable, if I want to be able to give this to everybody at work, but I want them to be able to spin up their own operating system in their own size, we need to parameterize it a little bit more. So what we're going to do is we're going to add a couple more variables. So we're going to go ahead and add the region variable. Did I spell that right? Yes. And then one of the things we can do with variables is we can specify the type that it is. So since this is a region, and region is like NYC3, SFO2, this is a string. And what I can do is I can set a default. So if you don't set this variable, then you're going to go to New York City 3, like that, the NYC3 data center. If you don't set a variable default and you put it in there and they don't require it, when you run Terraform apply, it will prompt you for that variable. Or you can again do it. You can always do it as command line args, which there's so many different ways of running Terraform. I normally don't get to that, but it is possible to do that too. Variable. The next one we're going to do is droplet count. So this is going to be like how many droplets I actually want to stand up. And we're going to go ahead and say this is a type. The type of this is actually number. I don't know why they didn't just go with integer, but we'll forgive them today. And then the last variable we're going to do is we're going to say droplet size. And we're again going to set a default, is set to string. And the default is going to be set to S-1 vCPU-1 gigabyte. So basically, this is the five. If you know anything about DigitalOcean, this is the $5 droplet. Okay, so now that we have all these variables, we're going to go just add them in here and change it. So this image, which I did not do, we're going to go ahead and change the region to var.region. We're going to change the size to var.droplet size. Now, I created another one called droplet count, and this is a variable that is a little bit interesting. So count, when you go to the DigitalOcean documentation, you're not going to see a count variable documented. And this is because this variable does not come from DigitalOcean. This is not part of our API. This is part of the Terraform API. So every resource has a count where you can basically tell it how many different of that particular resource do you want to create. Now, some it makes more sense than others. Like you can do it with DNS records. You can do it with almost anything. So we're going to go ahead and add that new variable, var.droplet count. And if I were to rerun this Terraform file right now, nothing's actually changed. We're going to only create one image. It's going to go in the same region that I originally said it was going to be in, and it's going to be the same size. So if we have our droplet running, and I just run it again, no change is going to come up, even though we have changed the code quite a bit because the values of it have not changed. So the last thing we're going to add to this. Oh, wow, that's it. The last thing we're going to add here to this real quick is we're going to add something called lifecycle. Now, this is another one of those moderately weird ones that shows up not in the DigitalOcean docs, but in the this shows up in the Terraform docs. So remember how I said if you were to change from 1804 to 2004, it would destroy the 1804 instance and bring up the 2404 instance. That's bad, could cause an outage. Now, if we had all of our configuration management set up to where whenever the 2004 image comes up, it configures, and we're going to pretend like it configures immediately and it's ready to go, and then we destroy the 1804 image, that would actually be a little bit better, because as soon as the 2004 comes up, it reaches out to Puppet, grabs the Puppet file, for instance, runs a Puppet apply, downloads all the things, the web server's up and running, boom, and then we can tear down 1804 and nothing will have been the wiser. That's awesome, and that's kind of what the lifecycle thing does here. So what we do is lifecycle, and we do create before destroy. And this is actually really valuable, and I don't know why this isn't the default. I think it's because if this were the default, in theory, you would incur more charges. If your Terraform apply takes hours, which they can, the bigger they get, the longer and the slower the API of the provider is, these things can take a long time, and it would incur you more charges. This is going to spin up all of the new infrastructure and make sure all of the new infrastructure is healthy before it starts a teardown. There is not a single piece of Terraform that I do not write that does not have this line in it, because I'd much rather pay a couple of extra dollars or a couple extra hundreds of dollars and not take down the corporate website. That's just me. So I always put this create before destroy here, and it will basically wait until the servers are healthy and then to start the teardown. Now, the caveat with this, and this is where it gets a little bit weird, is what Terraform determines is healthy and what you may determine is healthy could be two entirely different things. So your version of healthy might be the website, like GitHub has finished, like we've downloaded the code from GitHub, the server is running, everything's good. And that might run and work within this time frame and be perfect. But if you're like, oh, it downloaded this 10 gigabyte database that takes 45 minutes to run, that actually is probably going to fall out and cause an outage, because Terraform's going to be like, is the server up? Good, we're good. And then it's going to be done. It's not going to wait on, like if you have a separate tool doing configuration management, there is no way to trigger it and have it wait on that. Now, if you were doing some sort of config within Terraform, it would wait on that, but bleh. So it's kind of a shoot yourself in the foot situation, but it works really well. Just to make sure, because you want to make sure all the stuff comes up before it starts tearing down, and sometimes it can fail in that coming up process. So I've seen Terraform deploys where it tore down the old one and starts standing up the new one because they didn't have this, and then the new one failed. So now you're doubly screwed, because not only did you take down the services and cause an outage because you didn't do the create before destroy and you took down the new one before the old one came up, the old one was coming up, it failed, and now you have to debug why it failed, and you have no old one running. So it's a really, it can be, this is why DevOps engineers drink. This is why there were, like, they had, you know, as much snacks, free drinks, and alcohol at my last job as we wanted, because this is the kind of stuff that keeps us up at night. I'm getting flashbacks just thinking about it. So it's a great thing to do, create before destroy. I always highly recommend it, but it's not a catch-all for accidentally creating an outage. If you are really concerned about not taking stuff down, spinning up a duplicate set of resources, standing it up, waiting till you know that one's good, and then tearing it down, in my opinion, is the best way of going about it. It's the safest way of going about it. It takes a little bit more time. It's a little bit more manual, but that's what we get paid for. So that.
Well, once I assume you're going to get to this, but when I ran plan against this, it's asking me to now, for the output, use a count.index against.
Yes. Thank you for reminding me, because I would have forgot, and now that would have borked. So, and I would have thought about it for a second and remembered. Yes, now that we have multiple count ones, there is an index, like, we can't just say the IPv4 address anymore. We have to basically do a .* in between here. So this will be, because whenever we run the plan, you're going to see, if say we do 3, you're going to see it say, like server sub 0, server sub 1, server sub 2. It basically creates a list, and then it wants the index of that, and this is how Terraform decided to annotate that. So the last thing that we're going to cover before we run a plan real quick is the name. Right now, everybody would come up as web, which, not terrible, not great. This is where we have to do a little bit of the old school variable interpolation. So if you want to create a string and put other variables inside of it and kind of concatenate them all together, you have to do this janky Ruby stuff where you basically do web dash and then $ open curly bracket var.region and then dash, and this is the weird one that took me like 5 minutes to figure out, count.index, because as we saw, it's asking for an index. And then I do a +1 here. Because otherwise it would be 0, 1, 2, and I like seeing my servers as 1, 2, 3. It makes me happy. You don't have to do the +1 there if you don't want. If you like 0, 1, 2, whenever I need to know how many servers I have and it says 2, and I'm like, oh well, is it 0 or 1 base? I'd rather it just be 1 base. So like, there's supposed to be 3, and then I freak out and drink. So we do that with the count, and if we run a Terraform plan on this, I don't think anything's going to change. Because I haven't we're still within the defaults. Oh, nope, somebody's changing. Oh, I changed the name.
Name changes.
Yes, the name changes, but as we can see, it's just going to change it. It's not going to destroy it, which is great. Love that. So the next thing that we're going to do is, we could, actually, I guess I can do this real quick, if I can remember how to do it. How do I do the variables? There it is. So if I do a Terraform apply -var, and let's say I want to do droplet, what did I call it? Droplet count. Droplet count equals 3. I can manually specify that via the command line. And now as we see, it's trying to create 3 droplets, DigitalOcean droplet web sub 2, web sub 1, web sub 0. So it's going to try to create 3, and I don't want to do that right now. But I don't want to have to type all of that out for all of it. So what I'm going to do is I'm going to create a variable file, which is, we're just going to call it nyc3.tfvars. And what I'm going to do inside of here is I'm going to declare the variables that matter to me. So I want this deployment, the nyc3 variables, to be in nyc3, and I want the droplet count, I want there to be 3 of them. But the thing that you have to know is if I go into a Terraform plan right now, it's not going to show that. What we have to do is we actually have to do var-file nyc3.tfvars to specify, hey, I want to use this variable file. And now I see the 3, and it's actually going to try to change the one that I already have because it recognizes that it's not that far off, and it's going to go ahead and do that. So let's go ahead and just say yes. And as you can see, it says here, you didn't specify an out parameter to save this plan. So Terraform can't guarantee this exact actions will be performed. Terraform apply is subsequently run. I've never seen it not do that. But if you do, if you're being, careful, you can do out, and we can call it just plan. And this creates a file called plan there. And if we just do Terraform apply plan, and it doesn't actually ask for confirmation here because it assumes, you know, like this is what you wanted. It's going to go ahead and run the Terraform plan, and it's going to create these 3 droplets for me. If I go back to my console, as you can see, my droplets are going to come up here. And now I have these 3. So, and they're still creating here. It's still waiting on a little bit of stuff from Terraform. Sometimes it takes a little bit of time to get it through. And these are the server IPs of my droplets. And now just to show it, because I haven't shown it this evening, if you run Terraform destroy, I can tear them down. And that'll be done relatively quickly. And I can spin them up, and I can tear them down. And it goes way faster than I ever do at the console. Now, it's actually kind of silly. So what we're going to do, I know what we're going to do next. Okay. Good. Come on. So now what we're going to do is say we work for a small startup. We had those 3 servers. Now we're going to pretend that we need to expand into, we have East Coast presence. Now we need a West Coast presence. Let's go ahead and just deploy into the San Francisco data center. We're going to deploy into SFO2. We're expecting a lot more traffic in San Francisco. More of our users are on the West Coast. Let's go ahead and do 10 droplets. And because we're anticipating a little bit more and we need a couple more cores, we're going to go ahead and run, you know, the bigger instances. Now, if you don't want to run these, that's fine. If you just want to watch, because this is $100 a month worth of droplets right here. So actually, no, it's more than that. It's like 200, because I think the 2 vCPU 4 GB is a $20 a month droplet. So if you're worried about billing stuff, I mean, again, if you have a DO account and you need some, email me. I'll drop $10 in your account, easy peasy. But don't leave it running after tonight. Could get costly. So now if I do the same thing, if I plan, let's just go ahead and do SFO2. And because this is a workshop and because we're just trying to get through it, we can run a Terraform apply on this. It's going to pull up the plan. Like, it's going to show me everything it's trying to create. And then I'm going to go ahead and say yes. And this will actually take a little bit. This is where it actually starts to slow down, because the more resources you require of the API to create, the longer it just takes for all of them to get done. They have to get scheduled and stuff. And you'll see this across every provider. Like, whenever we used to spin up the clusters for the Mesos clusters at Verbo, it was about a 15 to 20 minute spin up for Terraform. So like, we would spin them up and we'd go like take a walk around the building or something and wait for the cluster to come up. So the more Terraform you add, the longer it takes to do it. And the more services you start like joining together, because some of them are very sequential. Like, I can't spin up a load balancer and point it at my droplets until the droplets are up, so it can't be run in parallel. Then it's going to take some time. Luckily, these are all droplets, so this should hopefully happen within about a minute.
Would you mind showing your plan again? Did it take down the New York instances?
I deleted them beforehand, but
okay.
if you did, it will, and that's a perfect segue into my next point. Because I'm about to do that I'm about to do the opposite of that. I'm about to show you the NYC3 one. So yes, if you ran a Terraform plan, it tried to delete your New York City one, and you might be going, well, why is that? Well, each TF state can only handle one run. So since we're using the same code but 2 different variable files, if I try to come over here and run a plan -var -file nyc3.tfvars, it's going to try to add 3 and destroy 10. It's going to try to tear down my San Francisco cluster, which is a problem. So this is where Terraform Workspaces come into effect. So what we need to do is we need to be able to create like a little isolated environment for every Terraform run to run in, so that way it can keep the state for it in that specific one, and then we can switch between the different environments and we get a different state for each one. So what we're going to do real quick is we're going to run Terraform Workspace new NYC3. So now we have created it and we've switched in NYC3. So now if I run that plan again, it's going to say 3 to add, 0 to change, 0 to destroy, because we are not destroying anything. There's nothing there. I hit apply, dash var, there we go. So if I run this really quick, we're going to get the 3 droplets showing up in NYC3. And there they are. So now that we have that, and whenever we want to go back to the other, we'll have to wait for the command to finish before I can talk about the next one. Whenever you're ready, droplets. When you work with Terraform, you spend a lot of time waiting. Okay, so now I can do Terraform workspace list, and it will show me the ones that I have. So we were always working inside of a workspace. We were working in the default workspace. Terraform automatically creates one for us. So if I want to make a new one, I do Terraform workspace select, that's the command, select default. And now if I do my Terraform output here, I'm back in SFO3. So workspaces are very valuable, or SFO2, are very valuable for us to be able to use the same directory in the same Terraform folder to configure multiple environments. So just a quick recap before we move on to the final part. We added 3 new variables: region, droplet count, droplet size. We specified the types they are. So if someone inputs the wrong type, it's like, eh. And we gave them default values, so that way, if someone was already using this code, it's legacy code, it didn't break anybody because nothing changed. The worst thing that it was going to do is it was going to change the name of the server. We put those in here. So basically, we created a count variable to allow us to spin up more than one droplet. The count variable, remember, is a Terraform variable. It's not a DigitalOcean variable. If you look on the provider page, you won't see it. You have to look in the in the Terraform documentation to see it. Region and size. We did some really fancy name interpolation, and we had to change this down here to the .star because we have multiple indices now, so we have to specify which one we want to do. Are there any questions about part 3 before we move on to the final part?
So I have a question.
Yeah.
I created the three droplets with NYC3 in my default workspace, and then I made a new workspace called NYC3, and then I did the same thing again. And now I have 6 droplets in NYC3. Mm-hmm. What's the process to undo that, or to get back to 3 droplets in NYC3?
I would just say pick one and then go and run a Terraform destroy.
Okay.
And then just delete it. So that way, I would personally delete the ones inside of default because I like having the fancy names. But yeah, you would totally just do a Terraform destroy and tear 3 of them down somewhere. My default is currently the SFO2 ones that have the large amount of droplets, so that's why I haven't done that yet.
If I delete that workspace, is it going to warn me that I won't be able to destroy, or will I still be able to access that state file?
I think if you know what, let's find out. That's a great question. Terraform, is there a workspace delete? Yes, there is. Let's find out. Delete NYC3. It's not empty, so it looks like it's not going to allow you to delete it before you. Oh, well, you can use the force tag, but as most command lines that have a force tag, it's best left not used. We actually, the one we internally we called ours at Verbo, we called it Blammo because it was a lot more like, you know, yeah, kaboom. You're gonna mess up everything if you do that. So don't do it. Okay. What are we doing?
I found it kind of interesting also that it seems like I exceeded my limit through doing it, and I got a response from the API rather than it knowing.
You exceeded your droplet limit, or?
Yeah, because you had like the 10 containers. And that
Yeah, I guess I should put that down. I'm not. Yeah.
I had 2 containers or 3 containers running in NYC, and I tried to do the 10 in SFO, and the last 3 failed.
Okay. I'm gonna remind myself to change that to like 5 because I forget that people have like a default limit.
I assume there would be clever ways that I could build that into Terraform to warn me before I did that.
It all depends on if the API supports it. That's all. Like Terraform is actually very. It's pretty Yeah, I wouldn't say it's not even that complex of code. The code complexity comes in the API. And if the API that you're hitting has that kind of protection in it, which I don't know if the DigitalOcean API does, then yeah, you could do that. But if it doesn't, then it's, yeah, I need to, there's a lot of like, also, if you find it as a bug, feel free to file it. And me and Andrew will discuss it on the DigitalOcean GitHub. It's under the Terraform provider. Yeah, I've learned a lot. I never peek behind the curtain, because when you do, you find all the bugs. And once I started working on the Terraform provider, I just want to sigh sometimes. But it's better put together than most enterprise softwares that I've ever messed with. I don't know if that's a recommendation or not. Okay, so any other questions before I move on to part 4? I'm gonna kind of have to blaze through this one a little bit, but I think it's gonna be relatively straightforward. Okay, we're gonna go ahead and go in. So part 4 is basically, what is part 4? Where's my slides? Resource dependencies, which is basically some resources require data from other resources to being built. Cloud init and how to use the user data. And then we're basically gonna build a complete infrastructure that has a DNS. If you don't have any DNS registered with DigitalOcean, then you're gonna probably have to skip that step, but I do. And it's gonna be a DNS record to a load balancer pointing at a website cluster, and it's going to load balance across the 3 of them. So the first thing we're going to do is we're going to modify the droplet just a little bit more. I'm going to make sure, oh no, I need to add another data source. So I could, again, I don't have to do this as data sources, but I like using data sources. It also means that I only have to change it in one place. So DigitalOcean domain, I'm just going to call it web. And then the name of this is going to be shark.codes. That's the domain that I own, that I use for like a lot of my demos and stuff. So now I have that. I'm going to be able to pull information about that. So that way, again, I only have to change it in one place if I want to change it. The last thing we're going to add really quick here, and this is going to be one of the biggest copy pastas ever. So if you're not getting this from the GitHub repo, this might be one of the commands you want to. So we're going to use some user data, and this is basically just raw cloud init data. So if you've never done provisioning with, if you've never actually dug deep into how cloud server provisioning works, there's a actually really cool Python script, it's written in Python, called cloud init, that basically is that the main thing it does is expand the disk. It can do a lot of other things, but the most thing is that when you create a cloud image, you create a base image of the operating system at the smallest that you can, and then whenever you spin up a cloud server, you expand that image to fill the disk, and cloud init does that. But it also has a lot of plugins and stuff, but it's also some really like dark magic, so most people avoid it. It's like SE Linux. It's best if we don't talk about it. So cloud init basically allows us to install some packages and then run a command. Basically what we're going to do is we're going to install Nginx, which is going to install it and also enable it, because that's what Ubuntu does. And it's going to run this command that basically is going to just create a home page for us and drop it into the Nginx Debian HTML5 file. So that way we'll be able to see the name of it. And when we go through the load balancer, you'll be able to see the number change, so you can actually see it round robining. That's all this is really doing. There are like Puppet and Ansible and like Chef and Salt like packages for this. So this is the cloud init config stuff would be one of the ways that you could have your system reach out to a configuration management system when provisioning is done. That is a talk all in and of its own. So that's about all we're going to cover with the cloud init. And then the next thing we're going to add is we're going to add a DigitalOcean load balancer. I'm going to copy pasta that. And we're just going to call it web-var.region. We're going to go ahead and put it in the same region that we are using. We're going to put all of the droplets that we create behind it. So this is where we have to use that splat syntax again. We're going to do pretty standard forwarding rules. So we're just going to forward port 80 over HTTP across. DigitalOcean load balancers, if you didn't know, does do SSL termination. So you can actually have it use certbot to create a certificate on the load balancer side, put everything in a VPC, and then pass it through and never have to worry about SSL certs again. I highly recommend it. Makes my life a lot easier. Again, lifecycle create before destroy. We always want to make sure we don't explode things that we're not meaning to explode. And then the last little piece that we're gonna, or the last resource we're gonna add is we're gonna add a record using the DigitalOcean data source. I manage my domains through DigitalOcean because it makes these presentations look that much cooler. So we're gonna go ahead and create a DigitalOcean record web domain, and then basically data.digitalocean domain web.names. That's gonna get to shark.codes. It's an A record. The name is just gonna be the region. I'm not getting really fancy with it. So it's gonna be nyc3.shark.codes. It's gonna point to all of this. The value is going to be the load balancer's IP address. So that way we can point it to it. I set a short TTL because sometimes I mess these up. And I don't want to have to wait forever for the TTL to expire before I can try again. Whenever you're ready to productionize this, you should definitely increase the TTL on this so you make all the people in Earth who manage the DNS servers not angry at you because you have a low cache rate. Makes it a lot easier. We're going to change this output to servers, and then the last one we're going to do is we're going to create a new output called load balancer. And we're going to call it value equals DigitalOcean load balancer .web.ip address. And that's about it for this one. And then we're just going to go ahead and run a Terraform plan. I should be in NYC3, NYC2. Given variables file NYC2 does not exist because I named it NYC3, then why did you bring up NYC2? Thank you for that. Thank you, Bash History. You confuse us all. Okay, so it's going to add 5, destroy. I'm in the wrong one. I'm in the wrong workspace. Terraform, workspace, select NYC3. It's going to destroy 3. Who's it going to destroy? Oh, because we're doing the cloud init data, it's going to force those old droplets to go away. So no biggie on that. And then we're just going to run apply. Then we run yes. And this is where it's going to start. This is where we're going to start seeing Terraform take longer. Now, the one of the things I wanted to show in this was the dependent resources. We use the IP addresses of the droplets inside of the load balancer. So what that means is it's going to serialize the creation of these resources. The droplets are going to have to create, and then we're going to create the load balancer. And then once the load balancer is done creating, then the DNS record will happen. So whenever Terraform starts to slow down, it's mostly because, well, 1, cloud APIs and provisioning, it takes time. It's not instantaneous. And 2, things start to get serial in a way that just make things take forever. And like droplets spin up relatively quickly, but if you've ever done load balancers in AWS, load balancers are going to take about a minute or 2. So if anybody has any questions while we're waiting on Terraform, day in the life of a DevOps engineer waiting on Terraform, it could literally be like a sitcom.
This finishes, you will have 3 droplets balanced by a load balancer behind a single domain name, right?
Correct.
And these are entirely independent of those 10 you have sitting in the other workspace, which happens to be in the same data center.
Those 10 that are in the other workspace are in San Francisco. The ones that we're standing up right now are in New York. No problem. Yeah, totally. That's what they're going to be. So they are, and I'm not going to run the command on that one because 10 droplets of that size takes a little while. So you're going to have to just believe me when it works this time. You're going to believe me that it works on 10, and it does. It's really fun. But yeah, see these load balancers. They take forever.
Do you have familiarity with Terragrant?
I've heard a lot about it. We never used it. I've had a lot of friends that tell me they like it because it basically does the aggregate. It integrates with like GitHub and GitLab, and it lets you like review stuff. Correct? Am I thinking the right tool?
I'm not really clear on the difference. It seemed like it was a wrapper on top of Terraform to kind of simplify some of the things, but I'm more familiar with that versus Terraform, so I don't really see.
Yeah, I think there's some things in terms of like being able to leverage like different backends or providers and stuff that it provides a good wrapper around that Terraform might not necessarily do natively, like right out of the box.
I feel like there's a lot more important before you could have like a shared remote state file.
Yeah.
Like tooling around that.
Terraform, yeah, Terraform I think was a hosted solution to like what Terraform Cloud would provide, because it manages the state, it keeps it in a remote space. It's really nice. The number one pain of most Terraform people that run it on premise is managing state files. It is a pain. So as we can see, you might be able to see it. I can't because the Zoom controls keep getting in the way. This is nyc3.shark.codes, and as I refresh it, I'm going to round robin through my servers, and we now have a load balanced stack that once we got through the 2-hour workshop, it stood up in like 2 minutes. So we can do this over and over again, and I have much more complex ones. Since the last time I gave this workshop, what is it called? I don't remember. Where is it? I have actually created a GitHub repository in the DO community called Terraform Sample Architectures. Actually, it's called a lot more than that. I'm going to grab it and post it in the chat real quick. And this is these are going to be, I'm eventually going to continue working on them, but I've just gotten busy. These are much more complicated solution or architectures that you can spin up entirely in DigitalOcean with one command of Terraform. The one that I do, that is the only one that's actually been fully implemented, is essentially the same thing, load balanced across the web, but it does HTTPS termination. So it SSL in, and then it's inside of a VPC. The web servers connect to a database, and there's a Bastion host for you to jump in and SSH in around and do stuff with. So if there are no more questions.
So Mason,
are there any questions? Yeah, go ahead.
That link you just shared, does I assume Terraform just auto discovers everything in a directory when you run? Like you don't have to have like a main TF that includes references to your other Terraform files. It just auto finds things.
So what you would do is you would git clone that and go into like the 0.1 minimum web DB stack. If you have nested configurations, you will, and you like custom providers and stuff, you will actually specify the relative path of those, and that's how Terraform will find them.
I see. But like, okay, that makes sense.
Yeah.
I had hopefully a quick question. I know it can be a deep subject, but in terms of your recommendations for someone who's like going from doing this on their local machine to like using Terraform Cloud or anything like that, like a intermediate, like what your best practices are, obviously like using a Terraform backend or something to control your state, but like the CI/CD process, like what does that look like? Do you generally see things where people commit and then something picks up on the commit and runs the change, or like what do people do for that?
So I can just give you the experience that I had when I was working at Verbo. We actually structured our Terraform files in a really weird way. But now that I think about it, I actually kind of like it. We had different GitHub orgs, like legitimate GitHub orgs for test, stage, and prod, and varying amounts of access to who could access them. And then what we would do is, so Verbo ran, at one point at most, we ran in 5 different AWS regions. So what we would do is if we had like the Nomad, we'll say the Mesos cluster for stage, we would have a directory, a GitHub repository for that, and every branch would be a region. So the branch files would be named NYC3, SFO2, all of that, and then whenever a push would happen, basically the Terraform, we did store state. I don't know how we stored it. I think we used DynamoDB. DynamoDB does lock. You used to be able to do Terraform locking with DynamoDB, and it would restore the state there. So the CI/CD, whenever a push was made to one of those branches, it would read the state out of the lock file and the state file out of DynamoDB. And if it's not DynamoDB, I apologize, but I'm pretty sure it is. I didn't set up that system. And then it would run a Terraform plan, output the plan, and then there would be a manual. Do you want to do this?
Okay. That's the key that I've been trying to lock in on, is like, how do you actually verify that no one's going to do something stupid?
Yes, and as much as we want to try to automate the human out of DevOps, it's impossible. There has to be someone with knowledge of the system who makes that decision, and we never, because that's how you get automated outages. And it's a beautiful thing. Like, you thought you automated your code, but now you've automated the outage, and it's beautiful. And all your shit's on the ground and it's not working. And it causes people anger. So yeah, keeping the human out as much as possible is good, but like when it comes to something, especially because like when you're a DevOps engineer or something, if you're just on the team like at Verbo that takes the images and makes the thumbnail, yeah, I would automate that away, because if that goes down, it's inconvenient, but it doesn't take down the company. When you're at the systems level, you can, like, I always used to tell people, like, the DevOps team could bankrupt your company in 30 minutes. Every DevOps engineer on earth could. If we were really, really pissed off, it could happen. Which is one of the reasons why you should keep us happy, which is why you keep the developer kibble on the side. That's what we used to call the snacks, the developer kibble. But there, you can't, I would never automate away that level, because I've seen some really fun outages before caused by automation. I've seen the funniest one, the one that made me angry the most, and now it's like, it's all funny after the fact, it's your pain, was whenever the old key, the thing that would basically, the key rotator rotated out all of my Terraform AWS keys in prod. And which was fine. I mean, as long as the system goes down, everything was still up, but we had no way of changing the system. So, and this was happening at a company, and like, you're like, well, the big companies, they do it better. No, they don't. They don't. I worked for a Fortune 500. They're just as incompetent as everybody else.
It's all a mess.
It's all a mess. It's all a mess. It's why we get paid so much.
I'm kind of amazed any of it works at all.
Yeah, right? You look at that and you're like, not only do I not know how it's working now, I have no idea how it ever worked ever.
It makes the global AWS S3 outage seem so much more understandable now.
Yeah. No, whenever we were a hybrid multi-cloud. So we had a physical data center in Austin, Texas, because that's where the Verbo headquarters was located. That's where I'm located. We have a new physical data center that they spun up in Ashburn, Virginia. And then there was 2 regions of GCP and then 3 regions of AWS. Every now and then the 4th one would come up, and then we realized we didn't need it. And so I got a lot of outage reports. And whenever I would read the GCP, like the RCA, the GCP RCAs, I'm reading through them and go, yeah, I can see that. That makes sense. Yeah, the automation took a wild turn and turned off half the data center. Yeah, nothing surprises me anymore. Everybody who's like in 2020, you read the news, like murder hornets and stuff. You're like, oh, nothing surprises me anymore. And DevOps engineers are like, man, we've been here forever. Like nothing has surprised us for years. Welcome to the club. So,
are there any other questions for Mason?
I'll check the
It's
chat.
been a really great workshop. I actually followed along the whole way, got everything to work. It's the best being a hands-on keyboard and things are working. It's very cool.
I'm glad it works. It's nice when it actually does what you're telling it to do. So let me check, make sure I have no more thingamabobbers in my slides. Yep, that's it. If you have never used DigitalOcean before, and you want a new account, there's a link to get $100 credit for 60 days. I do some live codings on occasion, so if you've enjoyed this kind of stuff, I've mostly been working on a Django app that is essentially a classroom management Django app tool that's going to basically allow a meetup organizer or someone doing one of these workshops to give students the ability to work with a very limited version of the DigitalOcean API, but it all comes out of one person's account. So you put one API token and then everybody can use it, and there's proper IAM. So that's going to be, that's pretty nice. I'm hoping to get some sort of release of that done before the end of the year. Also, Hacktoberfest is coming. If you aren't familiar with Hacktoberfest, it's the celebration of open source that has been sponsored by DigitalOcean. This is our 8th year in a row. And if you do if you get 4 pull requests in the month of October, we will send you some awesome swag and a really awesome t-shirt. So I'm not wearing mine today, but
that is awesome.
Yeah.
Actually,
Yes.
Is Hacktoberfest a DigitalOcean thing?
Yeah, we started it. We started it 8 years ago. It's a DigitalOcean community event.
Very awesome. Well, Mason,
Yeah,
thank you so much for being with us today. It's been so awesome to have someone to walk us through the Terraform maze and using DigitalOcean along the way. That's really awesome.